We are from CSC IoT from Aditya College of Engineering and Technology, and our project title is Arduino-based earthquake prediction using machine learning and deep learning techniques. My name is Anjana, and these are my teammates.
My name is Abhiram.
Myself, Satish. Myself, Hemanth.
Welcome to our earthquake prediction system using Arduino Uno. This project is built to monitor environmental changes and detect early signs of earthquakes using a combination of sensors and indicators. At the heart of this setup is Arduino Uno, which acts as a brain of the system. It gathers data from various sensors and processes it in real time. To display the readings, we have used an I2C LCD display. This model efficiently shows the live values of temperature, humidity and vibration and data without using too many GPIO pins. We are using MPU 6050 sensor, which combines a gyroscope and accelerometer. It detects any sudden pins or vibrations in the ground. If any abnormal movements are detected, it could indicate seismic activity. Next, we have DHT11 sensor, which continuously monitors temperature and humidity levels. Unusual changes in atmospheric conditions and sometimes accompany earthquakes, and the sensor help capture the data. There is also a vibration sensor connected, which detects physical vibrations or shocks on the surface. When an unusual vibration is picked up, it sends signal to the Arduino. To alert the people during abnormal activity, we have added a buzzer with LED. When the system detects potential earthquake signs, like strong vibrations or sudden movements, the buzzer goes off and LED blinks, providing both audible and visual warnings. All the components are neatly connected using jumper wires and mounted on a baseboard. This prototype serves as a basic model for an earthquake alert system and can be enhanced further with a real-time data logging or wireless communication.
A read Python script establishes a serial communication link between a computer and hardware devices like Arduino or sensor modules. We have specific COM port COM5 using a baud rate of 9600. Once connected, the script enters an infinite loop where it continuously sends the character A to the device every few seconds to request data. After sending, it waits briefly for a response and checks if any data has been received. If data is available, it reads and decodes it, then prints the receiving messages. This loop continues until the user manually stops the program, at which point serial connections are safely closed. This type of script commonly used for testing, earthquake detection monitoring. The modeling is a complete machine learning pipeline designed for classifying sensor data using deep learning models. It begins by loading the dataset from Excel file and encodes the target's labels for compatibility. Several exploratory data analysis plots are generated to visualize features distributions, correlations, and label balance. The data is then pre-processed by scaling the input features and reshaping them to fit the requirements of recurrent neural networks. The script trains three different models, RNN, LSTM, and GRU, each evaluated using matrices like accuracy, precision, recall, and F1 score. It also displays confusion matrices and for binary classification. After training, the best performing model based on accuracy is saved along with the scalar and label encoder for future use. Finally, it provides visual comparison of three models performing matrices, a bar chart. This end-to-end workflow ideal for time series classification tasks involving sensor data. These are the graphical representation and bar graphs, correlation heat map, box plot of sensor features, feature distributions, label distribution. The save data Python scripts communicate with hardware device to Arduino Uno over a serial communication through COM5 at a baud rate of 9600. It continuously sends the character A to request data from the device. When data is received, the script decodes it, extracts 6 numerical values representing vibration, accuracy, X, Y, Z axis, temperature, and humidity, and appends them to data frame. This data is then saved to an Excel file. New data is added to it, otherwise new file is created. The scripts run in a loop until manually stopped, and it ensures the serial port is properly closed upon exit. The UA prediction Python script is complete machine learning pipeline designed for classifying sensor data using deep learning models. It begins by loading the dataset from Excel file and encoding target labels, mobile compatibility. It creates sensor live data monitoring and classification graphical user interfaces using Quinter and Matplotlib. It connects to hardware devices via serial communication COM5, reads real-time sensor values, vibration, accuracy and gyroscope, temperature and humidity, and displays them on the screen. The values are also plotted live in scrolling line graphs. A pre-trained deep learning model, best sensor model, along with its scalar and label encoder, and loaded to classify the incoming sensor data as either normal or abnormal based on vibration values. The program updates the prediction label and sends corresponding signals B for normal, C for abnormal back to device. The program runs the data reading and graph updating in the separate thread to ensure the GUI remains responsive. అది నేను చెప్పేసాం కదా అది యాక్చువల్లీ
Readings, Mara.